Yeah, so just a simple view of what this is doing. It's kind of like a timing thing. I think the other one was good though too, that shows people actually have designed one, wherever that one was. This is a different one. Oh yeah, that doesn't show what it's transmitting either, but that one video did. This one, huh, was the ping pong ball. Geneva Cam in action, excellent. That's always helpful to have a quick. So it is a real part. Everything that we've drawn is probably really used for something, but that's the next one we'll draw is the Geneva Cam. So it's going to be, I think it's in inches as well. So I'll use the same PDF. It's use a B size sheet. So I'll probably just open up the B size one then, and whatever scale works. I think I do need beyond the A size sheet for this. So I'll just plan on the B size sheet template, and a section is required to do this one, maybe most accurately. Um, and and we'll explore why that is. But then I think I've got the same. So your sectioning is chapter 12, I believe. Yes. And these pages in your actual textbook will help you I think those are full sections, is what this one. If you remember when you did your sectioning stuff, they talked about half sections, which kind of look like quarter sections, but half sections, and and different. We have some offset sections. We get pretty creative with our sectioning, and we're gonna keep it pretty simple here, and just do a full section of this Geneva Cam for our two views. So, and it's a good candidate for wondering. You would wonder, do I need a top, front, right side? Well, we'll explore that for sure. We'll start with a front view. It's debatable though, like drawing this in a front view where you can see it the best is maybe not the most stable part position. So it may break that rule of my front view. So there would be an argument that someone might draw this cam laying down and not have great details, but it might be that the front view is just laying down in a stable part position and the top view carries all the data. I've drawn this one with just the front view and have dropped kind of the I've only drawn one. I've almost drawn my anyway. For stable part position, you'd have kind of it laying down on its flat, but you can see that I've just drawn it almost as like a top view and a section view is what I'm going to draw. This particular part is not sectioned in the assignment, so I'm going to open up this assignment sheet that just is the details for what I need to do here. So this is not necessarily, this is not how to dimension yours. It's just this contains the information to draw it. The keyway specifically I can tell right now is not dimensioned correctly from what we just learned on the ratchet plate assignment. So the other stuff is just to help me at least draw, and then I've got to determine later what is the key information. And I may already have these up here, pretty close. So I have your cheat sheet here a little bit, but I've only elected to do two views. But what I'm saying is, it could be arguable that somebody in the true GD&T world would say, let's draw this view as the front view, lay it down flat in a stable part position. This view would then become the top view, and then I could section the top view. So I'd kind of end up with three views. I'd end up with a front view that's stable part position that doesn't have great details. It's kind of it's a little bit confusing to look at. And then I would have that top view that's really clear and I can dimension the heck out of it. And then I would need to section it just to maybe detail some of the inner details with a section view. Um, yeah. Well, there's room. We always can scale down. Scale. Yeah, this has definitely been scaled up to fill the whole sheet with like, yeah. Yeah, surprisingly, this will look really big on a B-size sheet. Like we could do this half that size and still be nice and legible for a B-size sheet. The reality is our B-size sheet, we fill it up with our stuff, but it can hold a lot more parts details than we are putting on it. I could definitely fit a couple different parts on a B-size sheet, and even dimensioned out this much, I could fit quite a bit more. So, but I would have to have more parts to be able to fit there. Like I'd have to have the whole Geneva can assembly to then put some other parts that are associated with it on this print. But let's do this. I'll just open up my B size template. So, and start with that. So my templates, I have my folder up already. You should have downloaded the AS. This is the one I use. It has all the sheets, but I have the one that's just a B size only. So I'll do that one. Essentially, it was created from the same. It's just that I deleted them all. So here's just a B size sheet ready to go. And maybe I'll go ahead and name this, make sure it's not messing up your DWTs. This is a drawing that I've opened, so I'm going to save it as my in class. Geneva Cam. Yeah. Okay, so I'll pull up my PDF of that as well. So I have my PDF somewhere. In week 7, I should have my Geneva Cam in info. And I'm not taking I'll jump onto your screen again. Here we go, before I start drawing. Yeah, so this is my info sheet. So I'm gonna kind of start it like the ratchet plate essentially. I'm just gonna look to see if I can get some of these diameters dialed in here. So it is an 8-inch diameter out on the very an 8-inch diameter is the outermost and like so these if I really zoomed in here, the curvature of the top of this tooth here of the Geneva Cam is definitely radiused, and it's radiused by this 8-inch diameter here. So that 8-inch diameter really is only out to this point that's kind of been cut away where these two come into each other like that. So that these are on an 8-inch diameter. And then I have some other diameters here. Let me zoom out a little bit. But I've got, oh, this is a horrible dimension. 2.3. I wish that was 2.5. I don't know. I'll have to pull that open and see if that's true of the keyway. I'm just gonna I'll worry about that later. It's one of the last details I'll put in. Just worried about the outer profile first. So I've got that at 8-inch. Then I come in to a 4-inch diameter, and that's definitely what's driving the placement of these radii here, which are called out hopefully somewhere. Haven't looked at this for a little bit, but I think I've got a note on here too that rounds and fillets are 25. So unless they're explicitly called out, I've got a note that I've got a 25 radius because I definitely have a fillet here in my side view. And these, do I call them out anywhere? I'm gonna think that these are 1/4 inch then if they're not explicitly, if there's no local note, and I don't think there is.
On the assignment itself, there's it says the radius.
If I look at so I've got some other information on this one here, you're saying? And if you're looking at mine here, is it on this particular sheet though? Right here. Well, this is definitely this big radius here. That's a radius of 1.5. So let me go back to I really don't, what I was looking at is if this is explicitly called out, these ones in the inner ones here. I don't really see it. Oh, 1/2 inch right here. Yeah, Riley, I like this. So this definitely makes sense. That does match that, but this is the better, yes. That it's 1/2 inch. That means that's a 1/2 inch diameter or a 1/4 inch radius. That's good. That's definitely the one that's driving that size. And then this one is definitely the outer one here. Yes, with a radius of 4.5, clear out to where its center might be, center and center. So this is another one that's a good candidate for probably trying to draw these before I maybe would array them. Probably on the 3 or 9 o'clock position of this rather than here. So I think that information will allow me to get those scoops out of there. Those are 1/2 inch wide. There's 6 of those around. I mean, I might lay these out on the 12 o'clock or 6 o'clock position and array those around just because. So the way I view, like, just even drawing this is, um, and the way that I was given the dimensions are, I'm probably going to draw these deep slots in either the 6 or 12 o'clock position and array around 6 times. And these ones out here, I'm going to draw in the 3 or 9 o'clock position and array that around 6 times and then just trim everything to fit. So I'll put in a full circle first that it's going to be all trimmed out with the other geometry. And then I'll worry about the hub later. I'll worry about this. Clearly this has more of like a hub, uh, and this doesn't show the radius, so that's kind of this. Maybe this is a little bit misleading, but I'm going to put this radius in from one to the other. This is where I would say sometimes that's added or dropped on some. It's probably dropped because I drew this in CAD, and that's kind of hard to put in there. Would be my guess. And then I'm going to cover it with, I'm going to cover the actual geometry with a note here, and then at least show it here. But it's a little bit misleading that the isometric doesn't include that. I'm going to include that. And it doesn't even look like it's included here. I haven't like added the edges of the radius, which sometimes they're dropped and sometimes they're added. So you just got to kind of watch yourself. But because how this shows in the side view, I'm going to add them onto it here. So, okay. I think I've got the information I need to start this thing. So I'll jump over to my drawing model space. Good. I'll probably start with some center line. I'm going to keep those. I like to keep these center line, even though they kind of act as a construction circle. They're actually just kind of a kind of like a polar center line that helps me like associate some of the geometry to these center circles. Like I left them on my ratchet plate. I'm going to leave them on here too. So the first one I'm going to put on is that probably the 8-inch one. And it's arguable that I don't need that one as a I think I'll just put it as a center circle and we can decide if I'm gonna keep it or not. But I need an 8-inch one. That's really the whole part diameter here out to the outer. That's an 8-inch diameter. So I put four as a radius. I draw a lot most of my circles by radius probably, but well, I'm thinking of the part itself first. So what's driving my first one is this 8-inch diameter here. That's actually the diameter of this here. The 4.5 is clear out to a center line to actually locate these scoops that are out of that. So I'm going to do that one next. I've got a 4.5-inch radius one as well. So if I jump right back into the same command, there is a 4.5-inch radius one, but that's kind of helped to locate those big cuts in it. Yeah. I'm gonna put. Is there any other ones that I want? Let's see. Move this over. Yeah, There's a 4-inch one that I want as well to be able to draw the geometry. I want this 4-inch. Uh, it's controlling the deepest. The radius. How deep that radius goes in is on a 4-inch center. So let me do that. So I'm going to draw one more circle that has a 2-inch radius or a 4-inch diameter. I'm going to put in the center marks here too. I think that's going to help me. So I'll just use the outer circle here to put that in. I'll go ahead and extend that out beyond there. Whether that stays that way or not, I just like to always, while I'm doing this, maybe do my extensions or do them last is fine too. But if you might forget, and that might get pulled differently once the part gets drawn here. But I think what I'm going to do is go over my visible layer. I'm going to snap one right over the top of this one that I drew. So the 8-inch circle, I'm actually drawing right over the top of it because that's now I need to start cutting it into the shape that it is. And I could start drawing either, I don't know, maybe I will draw the big ones out on the edge. It's got a radius of 1, so I'm looking at this now. Sorry, if I pull it back up. Just trying to make it bigger. So I've got a center mark to go off of this way now. I'm going to come out to where that radius of 4.5 is and where it intersects that circle. And this right here, I wish this was extended past through this anyway, shows that this is the center for this particular circle right here. That's got a radius of 1.5. I need to come out 4.5 and then be on either the 9. I could draw it over here too. I could draw it at the 3 o'clock area, but I'm going to probably draw it out here at the 9 o'clock area. I'm going to look for that intersection point between this center x-axis center mark and where it meets that radius of 4.5. So I think I've drawn it a little clear here because they should intersect each other. And I need a circle that's 1.5. So I'm on the visible object layer. But yeah, I essentially show that I go out 4.5 to there, and this is what's driving this thing that's a radius of 1.5. So it kind of looks like what the cut would look like here. I already had it because I dropped this center mark in after I I drew these three radiuses. In fact, I put a visible line over the top of that one. So there is a center line under this one too. But yeah, I was looking for this intersection point to happen. That is 4.5 inches out from center. And it's on the 9 o'clock position, which my part has that. And now I'm just going to trim that, trim out my part. I'm going to array this around, but I think I'll just do the trim work. I'm not going to array that whole thing around. I think I'll just array around what I need, which is going to look like this. And so now that center line will start appearing as I trim out that. So that little piece is going to get arrayed around 6 times. I'm going to trim everywhere where it, so I can expose that 8-inch diameter. Yeah, I could do one array of all the parts, right? So yeah, let's do that. I don't know if that's what you're saying, but that's what you made. Yeah. Yeah, you could do, yep, totally. So I think I'm going to choose to draw that one right here. I think I could draw it at the 6 o'clock or 12 o'clock, only because it has alignment with the X and Y axis center mark that I have. I mean, that's how I was able to locate this one was or this one out here was because of the X center line and this so to locate this one, I'm going to use the 4-inch circle, and I'm going to go out here and just draw a circle and then extend the sides up to the 8-inch one that I have. So I think I'll put in one circle here, and I'm going to do it on the 12 o'clock spot because it's just easy. I already have a Y center mark through there along kind of the Y axis of this part. So let's use that rather than use one of these that's out in the middle of nowhere. I'm going to use either this one or this one to draw. So let's do that. So it's got a radius of, or it's a 1/2 inch wide, and really that center mark is right here. 0.25 is my radius there, but just like that. And then I'm going to take it from the quadrant up, or I'm going to take it from its being tangent, probably from being tangent. So if I took it from the quadrant, what I'm saying is if I draw this line from the quadrant, it may or may not be where I need to extend up. I definitely want it to be tangent to this and up. So I think I'm going to draw a line and I'm going to hold down shift, select tangent. And I'm going to say this line, I want it to stay tangent to that. And then I want it to stay up and down. So I could put on ortho mode, F8's on ortho to lock myself in. Or is it? Yeah. And then maybe or use your polar tracking here. What I'm looking for is like a 0. And I've got nothing. I got nada. It won't let you do that, huh? It's going to be a 1/2 inch out here. I could definitely go like this too. I could draw out here. So maybe I can keep on ortho mode and maybe I'll say from here out, I'm going to cursor over 0.25 and then I'm going to go straight down. And maybe it is the quadrant. I'm just doing a double check here. So I'm just going to say I'm going to trim this now. Um, because it's going to be where it is. But I do see, I think I just got to watch this a little bit carefully. Yeah. I'm just double checking myself, but yeah. I'm gonna do another line like that, and then I'll look at the grips that I have. Or I could mirror this across. I've kind of trimmed it to fit, so maybe I'll just mirror it, and then I'll trim out the. Yeah, I'm just zooming in to check here, but yeah, let's mirror this particular geometry over this line here. I don't know why that didn't work for me. Don't erase my source. And I should be able to trim this, right? On both sides of that. Yeah, it's kind of funny that it did trim that out, but it's kind of weird. I feel like I remember this being just a little bit like I don't think I'm going to trim that like that. I do think that it is on the quadrant, geo geometry wise. My circle's a little bit funny over here, though.
Well, yeah, in the vertical position.
Should be tangent. Mm-hmm. Mine kind of trims out funny when I trim mine like that. You get this weird misalignment a little bit. So just watch yourself here. Like it could be some funny geometry there, but let's do it. I'm going to draw mine 0.25. My line up. I'll try the quadrant this time and just see if I like it. I'm on ortho mode. Not my favorite. You can. I just trim mine off and I'm going to lock it in here. Or I just turned off my ortho mode. Sometimes it annoys me when it doesn't want to function. So here's quadrant when I trim this out. I think that's its natural. I think you can pick quadrant and have that be the most correct. I was just kind of exploring that a little bit. It does get kind of weird. Essentially, I want it to be tangent and up, so that should be at that quadrant point. Yeah, good. I like it. I'm gonna trim this out. So I'll lose that piece of the outer. Yes. This is all one part. I think I'll make this. I think I'll join all this just before I'm just going to join just this, not the whole thing, but just that slot into one selection. Here's a single selection. So now I feel like I can polar array this 6 times. So I think that's what I'll do is array this thing. I want this geometry and I want this geometry and I want it to be around this axis, center here. I want it to be 6, so the default is great for this. And I'm going to say, yeah, excellent. Close that array. And then I just need to do some trim. And it should have created all the geometry that will help me trim out what I don't need there. And if you found yourself to this point in a different way, it's totally fine. This is just a way to do it. It's not the only way for sure. Yeah, that's good. I don't know if I can join these into the array. Probably not. Like this is a single selection array. I don't think I can join these things, but maybe I can. I wanted to know if I could. I don't think it will unless I explode the array. If I explode the rail, then I could join everything. And this is actually a 3D drawing, so it's not like this is 3D geometry. So it's kind of like my orthographic ones. I don't worry about joining those all together because they're not going to be a cut file pattern necessarily or a flat pattern. It's 3D actually. So I'm going to draw in the hub for sure. And so I'll look at its sizing here. Yeah, we've got some other diameters, I hope. 1.5 inches is the bore with this keyway, which may or may not make sense. I'll draw it in that way. 3.6 by 2.3. It doesn't really tell me which way is which or which ways. I think is it height times width? I don't know. It's a little unclear. I could open up my drawing and see what I've drawn because I think this could be clarified a little bit more to know if I think it's width times height though, maybe. I think it's actually a 0.23 width though, is what I'm thinking. I think so. I'll open up my drawing and see what that is actually. But I can draw the hub first. So I got an 1.5 inches, and then this hub is 2.5. So 2.5, 1.5 inches. This would be the right way to, I mean, this has kind of got some ASME going on, but not exactly. So 2.5 diameter on the outer hub and 1.5 on the inner hub. So let me put that in real quick before I worry about the keyway. I got 2.5, which is 1.25. Then I got a 1.5, which is 1/2 or 3/4. And now we just need to know what that size is. So I will. I'll open up my drawing that I have and see if we can get some clarification on that. I think, yeah, I'll open up my actual model here for that information, and let me just do a quick measurement. 3/6 wide. And I thought it was the other way. So it's width before height, maybe is maybe that's the key that I should know that. By 2/3. I don't know where the 2/3 comes from. 3/6 by 2/3. This is a better dimension for that probably that I end up with 1.73. That's probably right then. 2/3 is from the apex here. So I think it's 2/3 high by 3/6 wide. So with that information, I'll go back over to my actual, I'll keep that up in case we need it. But so it says a 3/6 by 2/3. So I'm going to come over here and draw that in, and maybe I'll just cursor over. Um, 2/3 is from here up. So this is 0.23. It's from the top, and then this is 3/6, which I'm in the center line, so I just want to know what half of 3/6 is. 15, 16, 17, 18. Yeah, it's from the very apex. Yeah, so that's a good question, but I cursored up like out of my command here. Yes, it's from the very top right there at the 12 o'clock of that hub I've just drawn. I'm going to go up 0.23, and then I need to go over half of 0.36. So I brought up my calculator in case you always use your calculator. 0.36 divided by 2 is 18. So I'm going to go over 0.18, and then I'm going to go down to where it intersects again. So I've got my intersection point on, my intersection snap. And then I'm going to mirror that. So it's kind of like I did the other one. I'm just going to mirror that across this line here, or a line. Yeah, so then if I look at how that dimensioning worked out, this is the 3/6 dimension, 3/6 wide, 0.36. And then its distance here is 0.23. And that means down along the side, it's a little bit longer where it reaches down to that radius. 0.243 is what I actually have here, but 2/3 here, 2/3 by 3/6. Yeah, 2/3 from where the inch and I think it's 2.5 inch diameter that I have on this, where the 12 o'clock of that is 0.23 up here. Yeah. I'm going to trim this. Oh, I put it on the wrong one. Wait, did I? Is that, yeah, okay, that's good. I need to be 2/3 up from there and 3/6. Oh, good. Well, that's okay. Let's do this. Let's, yes, I think so. We can just move it. I'm going to move this geometry. I never joined it all together yet, so I'll just move it. It could be a little tricky to move that way if I don't have some construction geometry to move it. And then I'm gonna have to piece that back in. That's okay. Let's just do this. I'm gonna join it too, real quick. Yeah, it does make my life easier. Yep, it's kind of buried in the ribbon menu. I agree. That's my 0.23 line that I'm bringing down with it here to this point. Yes. I got to extend those a little bit. I don't know if these will extend back together or not. Oh, they will. That's good. That one won't. Well, what a jerk. I didn't bring that down with me, but I should have. I should have double checked that. It's funny that half my circle would extend, but half of it won't, where I missed. So I'm going to redraw this one, or I could grip them together, but I don't think I'm going to do that. What do you got, Isella? Yeah, they're on this sheet here. So make sure you have your sheets up so you can just, yep, 2.5 because it's shown here in its rectangular view, which is ASME standard for notating it. 1.5. Yep. Heck yeah. I've got to redraw one of mine because I just kind of chopped it up and so I want to redraw it. Yeah, I've still got to do a little work to mine. Much better though. I just got to extend these down and then I'll just double check their measurements. Just because I moved it and I didn't draw it in here in place, I just want to make sure that this is 0.23. That's good. And just make sure nothing changed on me. That looks good. 0.18 off center. Good. And I just need to trim the actual one. This is good. And whether you join all those or not isn't super necessary because I am looking at a 3D view here. I'm not seeing the fillets there, so I'll show that in the other. But let's my next view, my side view, instead of being just a normal right side view, is going to be a section view. And the one reason why is because if I'm looking at this sheet that is drawn, this is truly drawn as a kind of a front and right side view. Debatable on this. Obviously, this is not the most stable part position for a front view. So, but because this view, this right side view kind of fails us because it gets it's not super clear. I mean, like it does carry the overall part size, and and all these lines are projecting across. So I'm picking up all these like visible lines where this data is coming across. So I get quite a few visible lines across this when I'm doing a true right side view that are not things that I need to dimension per se at all. They just kind of uh, so the drafter should decide, well, this is not the best a right side view of this, and this comes into play on a lot of like gearing and a lot of cylindrical parts in general or round parts with details, machining details, or kind of like this is kind of a busy part. It does have a lot of machine work going to happen, or if it's going to be 3D printed, okay. And but I can expose some of those and be able to dimension more features in the right side view if it's a section view. So this is kind of like drafter choice, knowing and drafter like knowing when it is time to take a section, when not. Um, I think in general we should probably think of section views more than we probably do. Like if I see a lot of things, I should wonder. Like I would hope a section view comes into my mind and says, would a section view show this more? It takes that foresight to know what it's going to expose, and so let's do one here, though. Let's do a section view of this. So I'm going to take a section from 12 to 6 o'clock straight through. So we're going to establish like a cutting plane line. And these are kind of weird. Yeah. Yeah, I just have yeah, what do I have? I think I have a plane. Like, what's my layers here? I've got a plane layer, right? Yeah, so this is my cutting plane. So for cutting plane lines and viewing plane lines, I'm going to use this phantom green line that's a plane layer. And essentially, it's just going to be what? It's got phantom lines have their own line type. So it's going to be right over the top. So I'll go to my plane layer here and maybe I'll X out here for a minute. So I didn't jump over my plane layer, but I will. Plane layer. Sorry, I can't select it from there. I can select it from here. That's great. Plane layer. And then I just want it to be, so a cutting plane line just needs to extend beyond any of the, maybe the markups that you would have. And, uh, And some people will put this in later, maybe after they even apply their dimensions. And so I'm just going to put it in now just for a visual representation. Maybe I'll come back and like fine tune it a little bit. It needs arrows associated with it, and the arrows have a particular size. And they're cutting plane line arrows are double the size of your normal arrows. So they say they carry the same like ratio of like 3 to 1, right? Yeah, for whatever width it is, it's 3 times as long as it is wide. And our normal arrows on ASME standard are 1/8 inch wide by 3 times that long. Does that sound right? No, but I think they're an 1/8 inch long by a third of that wide. I don't know what they are. We'll look it up on our dimension style. It'll have that. And so we just want our cutting plane arrows to be large. larger than those. And then I also have to factor in some scaling on my drawing, maybe for my arrow size to really appear the right size, because some of the scaling is going to impact my arrow size where it's not really an annotative. I mean, there's a few different ways I could draw this to take care of that, but I'll just show you. I think we'll worry about the cutting plane arrows when I'm kind of going into my detailing with my dimensions. But I'm just so I'll at least establish the line so that I can just think about this, that I'm going to cut this thing through like cake, straight up from 12 to 6. So I'm going to establish that line, and generally these will like extend beyond everything by a half inch or so. Maybe there, I don't know if there's a you could probably correct me if you've read the text more recent than I have, but I don't think they really tell me how far beyond, but just beyond that I'm in kind of its own, like I'm establishing like a viewing plane or a cutting plane. And I just want to like clear all the geometry is what I think about. So I'm going to drop this line in. Oh, maybe I'll cursor up here like a half inch or maybe even maybe 3/4 of an inch above this. No, I just want to make sure I clear all the existing geometry that I have. And then I'm going to draw this thing down and through, and maybe I'll pull it to here and then I'll extend this about the same. I like to keep it symmetrical. So if I pull it 3/4 the other way, I'm going to pull it 3/4 this way. And that's going to be a cutting plane line. It's going to be really thick. Obviously, everything's the same line weight here. If I look at, remember on your status bar, if you ever want to look at the actual line weights associated with it, your status bar has line weight if you have it selected here. If you have selected line weight, then it looks like three little bars on your status bar. Mine are currently off. But if I turn them on, I kind of get an idea of what the line weights, they seem like they're overemphasized to me a little bit here, but I don't like to draw like this. They're kind of these ugly lines to draw on. So I like that, CAD is normally just drawing everything the same line weight until you actually PDF it or print it, plot it. But this allows you to kind of look. This cutting plane line is a really thick line and it'll overpower everything down through. It'll really overlap the whole center line. I'll keep the center line there though. I mean, it's debatable if I want to delete that one that's vertical because it's going to be swamped by this line. But yeah, that is one of your status bar items that you won't have unless you have it checked here. So remember, clear down to your far right, you have options to select what's on your status bar, and line weight is one of them. So I selected line weight, and then it's this teeny little three bars here that turn on and off. Yeah, it does. It's like the glowing neon sign. Exactly. I'll do that a few more times. Vacancy here. But what I'll end up doing when I come back to detail this line is I need to kind of when I do a cutting plane line, I need to think about which way am I viewing through this part. Like so when I cut it, what I'm going to do is expose like a new right side view. I think we understand pretty well now that when I'm looking at the right side view, it's like coming over to this edge here and then looking towards the right side, right? That's how I develop a right side view. With a cutting plane line, I have my option to go either way. I can kind of look left or look right. And you tell the viewer which way to look with the orientation of the arrows. And so in this particular part, I could really choose to look left or right, but I would then probably pull my view to either the left or right. So if I'm in a view that I'm cutting down through here and I'm still going to look to the right. And so I'm going to actually like when I come back here, I'm going to draw, maybe I'll add this on here. Um, these like if I'm just going to use a line because when I put my plane in I use a line, so I'll just continue to use a line I'm going to change it to a polyline in a bit, but just for a minute it's just that I'm going to say I'm going to go this way, and I think it's maybe about a half inch is what the ASME standard might be that I turn, and then I'm going to place an arrow on the end here, and maybe I'll show you how I would do that, and it might be wrong with my scaling, but I'll just show you how I would kind of finish this right now. And then we may have to fine tune it later. But essentially, what we would have is a line that starts to go in the direction that I want to go. So I'm saying I'm going to still view this as a right view. So now I'm going to turn my cutting plane line to the left, and then I'm going to put an arrow on it that's going to point to the left. And all that is telling the viewer that's you cutting through here now looking kind of to the left, which makes a right side view, which is kind of confusing, but you're already doing this when you're doing right side views. You just need to tell the viewer that's looking at your other view that you're going to create which way is this oriented to the other view. And so this is going to be a cutting plane line looking left and develop it as my kind of my right side section view. But what it needs is arrows then. So when I do arrows, I change the line type from plane. even though this arrow's, and I just change it to an object because the plane, the plane is a certain line type. It's like a big dash and two short dashes, and then a big dash, right? So I don't want my arrow to be like that kind of a line type. I want it to just be an arrowhead. I don't really have like an arrowhead layer, but I do, but essentially it's an object. So I choose visible object, and then I choose a polyline. And the reason I'm going to choose polyline is because you get all these other controls with a polyline that you don't get with a line. So if I choose polyline, and I come over here, and I'm going to specify the start point of this polyline, and this is going to be kind of an arrow that I'm building. So I need to know first off, like what is the dimension, and I need a double size arrow. So the first thing I need to know is that a normal, a normal like dimension arrowhead on our ASME 2 inch. We actually we told it that our arrows are going to be an eighth of an inch arrow size, which I believe that means they're an eighth of an inch long. So the arrow size here is an eighth of an inch long. Does that sound right? And then the width is a third of that because they're a 3-to-1 ratio. So what I'm telling you is doing arrows like this are kind of a pain, but yeah, so like I think the 0.125 is the length of the arrow when we specify arrow size in our dimensioning, eighth inch. So divide that by three. Essentially, if that's right, or is an eighth inch wide? I think that you guys should tell me. You've read the book here. Tell me. No, I'm gonna come in here real quick and just drop this on here real quick. I'm gonna drop a dimension on here, and this will help me. This will help me. Just any dimension. I'm gonna do like a linear dimension here. Well, I don't have a lot of linear options here, but and I'm still a 1-to-1 here. So if I just do a quick like measurement, this is me like checking if I know what I know. So yes. So when you're specifying arrow size on your dimensions, you're specifying the length, which is what my gut was telling me. These are an eighth inch long normal arrowheads. They are a third of that distance wide. I just kind of need to know this because I'm trying to make a double size of this. Like cutting plane lines, their arrows like to be double sized. They're a bit more of a bold, they catch the viewer's attention. Um, so these are your normal arrows are this. So that was just me double checking myself. I'm going to go back out to my model now. And so if I have an arrow, this is actually the width of my arrow is 0.04. So double size that. I'm going to take that and times it by 2. Essentially, the width of my arrow for this to be double sized is going to be 0.08 if my drawing was staying 1-to-1. So that's the other thing I'm gonna have to worry about later. But I'm just gonna show you how to draw an arrow while I'm kind of in the moment here, and then I'll worry about how it looks on my drawing once I start working with it, and I'll see that it's maybe I need to change it to an annotative type object, which maybe would help me size it, or I can actually consider my scale on my drawing and resize my arrow to kind of uh, be correct size and not get like crazy big or crazy small again. So in this case, it's going to be 0.08 wide, and then it's going to be times by 3. It's going to be a quarter inch long. That makes sense. It's like an eighth inch long in generally, and these are double size, quarter inch long. So what you do is what polyline you have control over those kind of features. So I'm on the object. I'm going to draw my arrow as an object. I'm going to use a polyline, and then I'm going to say my arrow starts here. What you have is you have with a polyline, you get the command line that has all these options to do different things with a polyline. It's a way more dynamic line type. One of the things you have is width down there. So I can actually come down here and select width of my polyline. And I want it to be, if my drawing was really staying 1-to-1, I would want this width to start at 0.08. That's a double size arrow width. I'm going to hit enter. And then it wants to know, specify the ending width. Well, it's going to be 0. So I'm actually going to make an arrow point. So it's going to be like 0.08 wide where it starts, and then it's going to go down to 0. So I'm going to say 0. And then it's going to want to know what the length of this is. And see, it already starts to look like an arrowhead because it's a polyline that you've like got control of as like a width of a polyline and then a length of a polyline. We want it to be 0.25 if this was all staying at 1-to-1 scale on my drawing. So what I've essentially just drawn is I've used a polyline to draw an arrow. It's an object. It's on my object layer just so it doesn't like, if this arrow gets big, it would start to show the line type through it. So I just put it on a layer where it's going to be solid. Visible works for me. Yeah, go ahead, Lydia. I'm going to do it again. You want me to do it again? Yeah, yeah. I could copy that and move that now, but I'll start it from scratch down below again because it is kind of a weird thing. We don't do these a lot. We do a few cutting plane views and we make these arrows, but um, I was gonna just see if I can choose this to be an annotative object. I'll look into that a little bit if I can make this a smarter object to size for me automatically. But what I did is I turned these back a half inch. So technically these are 3/4 of an inch past this. I think I drew them 3/4 of an inch past this line here, right? Yeah. And then I turned them back a half inch. Those are just lines. And so they're separate lines. I could join them or whatever. If I need to move that, I could. If I need to move my cutting plane, I would join them to move them. But to just so I'm on, so what I did is after I did those on the cutting plane layer, I switched over to object layer. I chose polyline. They're going to start right here at the end of this line. And then just before I start drawing, otherwise it's going to look like a normal line because polylines really look like normal lines. But I can control the width of it. So I went down here. You can either type in W or I actually just came down here and cursor selected width. And then it wants you to put in the width, specify the starting width. Well, it's double the size of a normal arrow, so that's 0.08. That's how wide a double size arrow would be. Then it wants to know, well, what's the ending width? It doesn't know how long this is yet, but it knows that I'm going to go down to 0. So I just put 0 as my ending width, and that already makes it look like an arrow. This is kind of an AutoCAD hack way to make something, right? This is like using the commands I have to make geometry that I need. 0.25 because there's no arrow that's this size that I can just drag and drop from a menu. And it's 1/4 inch long because that's 3 times as long as it is wide. That's an ADDA question, I guarantee. What is the relationship of arrowhead size? Well, it's 3 to 1. Sometimes I have a 3 to 1 that's a double size arrow for cutting plane lines, and sometimes I just have a normal 3 to 1 eighth inch size for the normal dimension arrows. Just remember that 0.125, the ancient size that you would select for your arrowhead size and your dimension style, that is specifying its length, and its width is 1/3 of that. It's confusing, and we haven't dissected that too much. That's why I wanted to kind of nerd out on it right here. But this is essentially if my drawing stays 1 to 1, and I'll go over here and like find it in my drawing space now, and I'll unlock it and I'll find it in here somewhere. So if my drawing was staying 1 to 1, which means it's going to be this big, and I'm going to position that so we can see the arrow. And that's going to be the arrow. That's how big the arrow is going to be on my paper. It's just a double-sized arrow. I think this thing is going to scale weird for me though. So let me just try a scale. And I'm going to go to a half size. Um, I don't know. This might every once in a while. I think I have to consider the scale of my actual thing when I get to this point, but because I think it just stays at same size, whether I'm at double size or 1 to 1. And essentially, I want it to be like an annotative thing that kind of scales up or scales down to keep its shape. So I may need to come back and consider its size once I've decided what scale my drawing will be at. But until then, I'll just leave it and then I'll decide later. At least I've got it kind of captured. The reason why I wanted to put it on there is because I want us to know that I'm cutting through this thing and now I'm looking to the left, which makes me draw kind of to the right side of my object. So I wouldn't want to cut this through and then draw this view on the left side of the object. That's like not something that anyway, I would want to like put this on the side of the object where I'm viewing it from. So to me, even though I'm looking left, I'm gonna put it on the right of the object. Yeah, essentially I'm like removing all this. Like I'm gonna draw this view with essentially from the cutting plane line to the right. That information is gone to me. Like I don't want to see any of those object or visible lines at all. I just want to cut through it and pretty much ignore everything from the vertical line center to the right. I'm just almost like pretending in this next view that doesn't even exist, and I'm just looking right where that cutting plane line is. And so the right side view then becomes like where that plane is cut through, and everything to the right of that is gone. If I turn my arrows the other way though and pointed the other direction, it would be like everything to the left would be gone to me and dead to me. So yeah, yeah. So now I have to draw this next view, thinking that all of this doesn't even exist. So that's what I'm going to do. But I'm going to use projection material. I think I'm going to use construction material and just do a projection over. I just need to. I don't have to be too concerned about the spacing. Like I want it to fit on my drawing, but we know we can always add a viewport. And so to me, I start to not be so concerned about that now, knowing that I can just always grab a viewport. I need to dimension it anyway. I don't want them to crash, but I'm just not going to like spend the time and effort to perfectly place it. I'm just going to keep it an orthographic projection though, for sure. So I think I'm going to project over my 8-inch diameter. This really controls the overall part width over there, or I should say the height of it. But but really it's not the part itself because it's like my part really doesn't capture this. Anyway, what I'm saying is I'm going to drag this over here some unknown distance. I'm going to drag the top. It's just like I'm going to build an orthographic projection now, but kind of a half orthographic projection. Like I'm not going to do much more than just need to project from left to right. So that's going to be the overall part size. Of course, my part doesn't really start there. And then I might just say I'm just going to plop it down right here about and give myself some room in between these views. So I think I can kind of determine the overall part width from the PDF, right? Like I've got this. It tells me that it's 1 inch. So this is good. I can drop a rectangle now or just draw two more lines that are spaced down about an inch apart. So I'll do that. That's one reason why I need this view anyway, is to get that width. I don't get that here. So I definitely need a view that shows that. So you could either do a rectangle here and drop it somewhere, or I could just do two more lines. Maybe it comes in here somewhere. That just happens to be the center line of the line width I drew, which is of no particular length, but that might still give me enough room. And then I'm going to repeat that line that's over an inch because it's an inch wide overall. So my part's going to, that's going to be my controlling view size right here. And then I'm just going to start projecting information across. So that's overall part size. I'm going to need to, I'm actually going to need to project that little piece across potentially, and this little piece across. And I know I'm going to use this side, even though I told you this information is dead to me now because I'm looking this way. So I'm still going to use it to do my projections probably, because what's going on over here is what's going on over here. I could take my projections from clear across if it helps understand that better, because technically I'm looking at this half of the part. So maybe I will, just to even cause more confusion. But so these are going to be really close together. Between the one I just took and that one is just slightly lower. So I'm going to take that piece over. That's actually a visible line that I would see over here. You can see how close it is, like that. It's going to be there on top and bottom. Sometimes I try to work uniformly so I don't forget a line. But essentially, I know that the real part just dips just below that. So I'm just going to project. It's really close, but I'm actually going to have nothing drawn from there to there because it really doesn't exist. My part, when it's sectioned, starts right there. However, to build the part, I really need to have an eight. I need to be able to do an 8-inch diameter to get this right curvature in the top of this tooth here, essentially. Yeah, that's complicated a little bit, but the other thing I'm gonna likely see is this part right here, right? Um, if I'm viewing, it will be a hidden, if I'm viewing from here over, it will be a hidden line though. Like this next one that's just gonna barely dip below those other ones is gonna be a hidden line in this over here. I'll project it across top and bottom. So these are just some of the fine details of how this top of this tooth will look. The first one I drew closest to the line will be a visible line. This one will be a hidden line, just because if I'm looking from here over, that's definitely going to be hidden line. These ones are going to be hidden lines as well. Whether I put all these in is debatable, probably. Um, so maybe I'll wait on these, but you can see all this data might come across as hidden lines. All these points are going to go over there as hidden lines, all these points down here, and of course the two I just took, top and bottom. But let me move on to just maybe the radius of this slot. So this is also going to come across. Um, if I cut through right here, yeah, go ahead.
Where we're taking away half of the year, when we just not have half of those lines.
Yeah, the hidden lines.
Yeah, like the ones that.
Yeah, well, I would still have like if I'm viewing through the part, they would still like I think there are some I think there's some gray areas on what I include and what I don't include in section work. And sometimes some section they'll choose to omit some of the hidden lines and just yeah, if you remember reading that, that's probably in the so yeah, good. Yeah, I may omit them here. So now I'm going to go back to what I really can see. I definitely am trying to differentiate the top of this, and that's why I pulled those dimensions off the top so I can kind of keep track, or those projections off the top so I can kind of keep track of what's what there. I didn't do any more hidden line work yet because it's going to get kind of busy. I'm going to focus on features that I can really see now, which are definitely going to be the inner bore. If I'm cutting through here, and that's like this is going to be a visible line now, like where I cut this through. I'm not going to be able to see that it's radius in this section view, but I'm going to be able to see the apex point there, and then I'm going to be able to look at this edge there. So I'm going to project this one across and the lower one across. I don't know if that helped. I mean, yeah, good point. Sometimes I project stuff across and I'm like, well, maybe I don't need that, but I thought I might need it at first. The other thing I might need is I'm going to cut through here and see this material now. I would kind of expose this through. I'd be cutting right through material here. So what I'm going to do is pick up any features that I would be cutting through. So I'd have this point that I would see, and of course its opposite point right here. Like I'm going to expose something going on there. And then I'm going to work down through here and I'm going to say, well, I'm going to expose some of this keyway now. This is going to be exposed in this view. And I'm going to definitely expose the bottom of the bore here. And really, I've got some keyway stuff I'm going to expose. So really, I would expose this one. This, and that might be all I expose there. Yeah, so now let's try to make sense out of what I've got going on here. So I've got like the 2.5 inch diameter that I'm going to draw over to the 1/2 inch diameter. So maybe I need to draw another line down that's a 1/2 inch. But I think I'm going to cursor over and just trace that in with like visible line work. Yeah, I think so. Yeah. Remember what you're looking at here is a true right side view. So you're picking up those visible lines, and some weird hidden lines for the keyway. But let's go back over and try to make sense out of this. Yes, well, with some visible line work. I feel like I'm going to do the 2.5 inch bore. Maybe I'll just start with this one here. I feel like it goes in here, and then it goes in a 1/2 inch, and then it goes up. And I might just pull this only up to this. It doesn't go clear up to here. To me, it stops right here. And then it comes across. And then it goes down to the other opposite side here, which is that one that's close there. And then it's going to go over here a 1/2 inch, right? And then back up to the diameter of this one right here, right there. And then back out and then back in this way. Ooh, that's kind of tricky. It's kind of the outer edge. It does have a radius there. It picks up a radius right here. So I could put that in. If I do a fillet radius, it's a 1/4 inch. So if I do my fillet and I want to do my radius, R for radius, and then 0.25 was the radius on the fillets that were not specified, but this one is from here to here, a fillet. And I'll repeat that fillet and I shouldn't have to preload the information, just use it.
The orthographic view of the, like, just the assignment page, there is no filling.
Yeah, I think that here, right? Or yeah, just right here is where I was picking up. But yeah, I definitely think that I think I remember drawing this in 2D CAD as 3D. And I remember it being hard to depict that. It made for some hard eclipse rays there, something that I omitted. And so this is one where I think, and we always come to this point to where, like, do you show them or not? Doesn't show them well here either. It does show it right here. So it's more of a blended feature where they didn't show, except for you should pick it up here. I agree there. I think I have an additional part that probably shows that in Inventor with that radius, and I probably should swap this image out for an Inventor part. This was a hard one to draw in 2D actually.
Yeah.
It took me a little while. I didn't try to revisit it this year. I did that one last year, I think. So then I have to think of what I've exposed and what's visible and what's not hidden here. So if I've cut through right here, this line right here will now be a visible line. So this kind of like this, the bottom of this will be a visible line where I've cut through that now. So it's like a bottom here. This surface that I'm looking at here is this surface right here, where this line is now this surface. So this is kind of radius coming towards me, and then, or sorry, right here is radius coming up, and then it goes to that surface. So if I come down from there, I've exposed this, but that's really only there like it shows. So there's no other like hidden line through there at all. So that's done. If I come down to here, this will now be an exposed line. Like this will be a visible line at this point now, where the top of that key way is cut, which is this. I see this. And then it would expose this too. If I've cut through here, I would see this edge now as a visible line right there, that little corner, that lowest. It's not at the 12, it's not the height of the it's not the height of the it's just down low. Yeah, anyway. It's hard to explain, I guess. But I'm gonna put this one in right here. That's kind of where I would see that inner bore show itself there. And then I would have this one as a visible line now. And that one we've already addressed. So I just have the one more to do across here. So I'll repeat this as the lower inner bore line here. This would normally be a hidden line if it was a true right side view, because I've cut through it, I've exposed it. So really, if I'm just turn off my construction lines for a minute, and it looks something, oh, I need one more. I need the bottom. I need that one right there. So let me put that in. I don't know if I even projected that across. I did. I just didn't trace it right here. Oh, and I'm on construction layer, so let me undo that again and do it on the real layer. Yeah. And what you have going on here is we have like a surface that we're seeing now that we've kind of exposed on both top and bottom of this. We have this material here, which we've really cut through right here. So this is what this is material that we've cut through here and here. So if I look at it here, it's just this material from that point to this point, and the material from this point to the inner bore is where I'm actually cutting through material there. So most of my cutting plane line is actually cutting through no material at all. It's just in the space here. Then it cuts through material, and then it's in open space again, and then it cuts through material. So and so what we do is we put in this hatching or some section work to show that we've cut through material. And so if I go to my hatching now, I think I have a layer for this. Yeah, sectioning, I think I call it. Section layer. It's magenta colored. There's small line weights. Section magenta. So that's what I'm gonna go to that layer section. And I'm gonna go to this hatching, which is in my draw. I don't think we've used any hatching yet. So hatching is maybe a new one. Hatch right there. It looks like a little crisscross pattern. So I'm just gonna do a hatch. You can do different things. You can set a boundary, do gradient. I'm just gonna do a simple hatch. It changes your ribbon menu to give you some control over what kind of hatching you're doing. Really wants me to pick some points. So you can see as I hover over, it's going to try to place this in geometry that's kind of closed. If your geometry is not closed, meaning if your ends don't come together and you have like an open loop, then the hatching doesn't know how to interact with that. So if you're ever having trouble with this and you're going to an area where you're trying to hatch and it won't hatch, it's probably that it doesn't have a close. There's some opening somewhere that's not allowing it to be a closed polygon or some closed geometry shape. So just watch for that. If it doesn't work automatic for you, it's because that's probably going on somewhere. You've got some boundary that's broken in your geometry. So you could use join to try to figure that out, right? I could if I couldn't get this to join, I could sit here and try to select everything around here and get it to join as an indicator of maybe where I could find where it's not joined. So on one layer. Oh yeah, yeah. As one command, right? You're right about that. Like if I choose to hatch and I choose this one, yeah, if I only do yeah, exactly right. Like this is the only one that's associated with that hatch. If easy to delete or easy to edit because they're all kind of part of the same hatch command, right? Yeah, yeah. So, and there could be reasons why I would want to separate those so that what I do over here to this hatch, I don't want it to affect this other hatch. And I think this is actually loading a default type of hatching. So, uh, ANSI, yeah, ANSI 30. And this is actually what I want. This is general. If you remember in your book, I probably have this listed in the assignment that there was a chapter that showed some different hatches for mechanical. This one, yeah, there's steel, there's aluminum, there's different types of materials in architectural use. Some of these probably that are preloaded for some of your different yeah, yeah. So they've got some stuff loaded for architectural, for civil, for mechanical. Um, let's see what else. So there's quite a few here. Yeah, different gradients. They have quite a bit. I think the first one is ANSI 130. This one works for it's cast iron, but it's also general purpose materials as well. So it is the correct hatching for cast iron, but it's also double functions as a general hatch. And so I'm going to go ahead and use it. And it is what was default loaded on mine. Is this just simple hatch pattern? ANSI 32, I think, is steel, specifically steel. So cast iron is different than steel. Think of cast as being poured into a mold of sorts. And it can be all kinds of different, it doesn't have to be cast iron. It can be cast aluminum. It can be cast all kinds of different cast steel recipes. So cast iron just being one. So I'm going to pick that one, and then I'll pick this one too. And like you said, I'm not going to really change much. It is marked already to be associative, which means the spacing of the hatch will kind of scale for me on my drawing. So I like that to be maybe annotative will help me do that too. I'll pick annotative. Maybe I can pick both. Let me close this hatch. I didn't change anything else, but you have so many other controls over this hatch. I think when I close this, it's gonna maybe when I select it, there's like a point that's a certain this is like the geometric center of the hatching that I've applied. So this is going back to what I already said. These two are kind of combined under one command. So what you do to one is going to affect the other. There could be reasons why you'd want to keep these independent for some reason on a different view or something. I probably would not like have different section views and just do all their hatching under one command. I'd probably break these down into views, would be my preference probably. But yeah, that just shows that you've cut through materials, what you're saying there. And everything else we didn't actually cut through. We actually had a bunch of empty space and it's visible line. And that's probably a good place to stop for the day and pick it up tomorrow and start dimensioning it really is what I'm ready for. What I can't remember is if I'll even look at my little cheat sheet that I have ahead. I can't remember if I did a lot of hidden line work in that or if I didn't. So it looks like to me, I omitted if I look at the cheat sheet here, it looks like to me, I omitted any of the hidden line work that might show. And I do think that's probably ASME standard that you would omit hidden lines in your sectioning. You're usually looking to clarify internal components and to be able to dimension them appropriately. And so um, we're not going to dimension to hidden lines anyway. So our section views don't need to carry those hidden lines because we're looking to actually expose stuff to dimension generally and to clarify. And so that's what this is all about. Of course, I need a title, a section title. I need to label my cutting plane from point A to point B, but we just label them A to A essentially, and that becomes section AA. And my next section that I'd cut if I needed a different one would be BB, and I would just continue through the alphabet. But I do like to establish that this is a section from point A or from one point to another point and label it accordingly. That's why section AA is what that is. So I got to add those on there. It looks like I'm going to do a bunch of center lines that I probably don't have, probably for dimensioning purposes more than anything. All the center lines that I've added here probably will expose themselves once I start to need a dimension somewhere. And of course, I have round features in my section view, so I'll carry their center lines. The bottom of the radiuses, the center of the bore. The vertical one is debatable. Do I need it? But it shows some part symmetry. I think I end up maybe dimensioning to it. I don't know exactly if I used it. I didn't use it for much, but I did put this vertical center line through there. That's debatable if I need it. Probably could omit it, but we'll finish it tomorrow. I like it. It's good. This will be part A. Yep.